The Aérospatiale (BAC) Concorde is a British-French turbojet-powered supersonic passenger airliner that was operated from 1976 until 2003. It had a maximum speed over twice the speed of sound, at Mach 2.04, with seating for 92 to 128 passengers. First flown in 1969, Concorde entered service in 1976 and operated for 27 years. It is one of only two supersonic transports to have been operated commercially. The other is the Soviet-built Tupolev Tu-144, which operated in the late 1970s. Concorde was jointly developed and manufactured by Sud Aviation, more than 30 times the cost of the cheapest option to fly this route. The original program cost estimate was £70 million. The program experienced huge overruns and delays, with the program eventually costing £1.3 billion. It was this extreme cost that became the main factor in the production run being much smaller than anticipated. Later, another factor, which affected the viability of all supersonic transport programs, was that supersonic flight could be used only on ocean crossing routes to prevent sonic boom disturbance over populated areas. With only 7 airframes each being operated by the British and French, the per-unit cost was impossible to recoup, so the French and British governments absorbed the development costs. British Airways and Air France were able to operate Concorde at a profit after purchasing their aircraft from their respective governments at a steep discount in comparison to the program's development and procurement costs. Among other destinations, Concorde flew regular transatlantic flights from London's Heathrow Airport and Paris's Charles de Gaulle Airport to John F. Kennedy International Airport in New York, Washington Dulles International Airport in Virginia, and Grantley Adams International Airport in Barbados. It flew these routes in less than half the time of other airliners. Concorde aircraft were retired in 2003, 3 years after the crash of Air France Flight 4590, in which all passengers and crew were killed. The general downturn in the commercial aviation industry after the September 11 attacks in 2001 and the end of maintenance support for Concorde by Airbus contributed to the retirement. The origins of the Concorde project date to the early 1950s, when Arnold Hall, director of the Royal Aircraft Establishment, asked Maurienne Morgan to form a committee to study the supersonic transport concept. The group met for the first time in February 1954 and delivered their first report in April 1955. At the time it was known that the drag at supersonic speeds was strongly related to the span of the wing. This led to the use of very short span, very thin trapezoidal wings such as those seen on the control surfaces of many missiles, or in aircraft such as the Lockheed F-104 Starfighter or the Avro 730 that the team studied. The team outlined a baseline configuration that resembled an enlarged Avro 730. This same short span produced very little lift at low speed, which resulted in extremely long takeoff runs and frighteningly high landing speeds. In an SST design, this would have required enormous engine power to lift off from existing runways and to provide the fuel needed. Some horribly large aeroplanes resulted. Based on this, the group considered the concept of an SST infeasible, and instead suggested continued low-level studies into supersonic aerodynamics. Soon after, Johanna Weber and Dietrich Kuschmann at the RAE published a series of reports on a new wing planform, known in the UK as the slender delta concept. The team, including Eric Maskell, whose report, Flow Separation in 3 Dimensions, contributed to an understanding of the physical nature of separated flow, worked with the fact that delta wings can produce strong vortices on their upper surfaces at high angles of attack. The vortex will lower the air pressure and cause lift to be greatly increased. This effect had been noticed earlier, notably by Chuck Yeager in the Convair XF-92, but its qualities had not been fully appreciated. Weber suggested that this was no mere curiosity, and the effect could be used deliberately to improve low-speed performance. Kuchemann's and Weber's papers changed the entire nature of supersonic design almost overnight, although the delta had already been used on aircraft prior to this point. These designs used planforms that were not much different from a swept wing of the same span. Weber noted that the lift from the vortex was increased by the length of the wing it had to operate over, which suggested that the effect would be maximized by extending the wing along the fuselage as far as possible. Such a layout would still have good supersonic performance inherent to the short span, while also offering reasonable takeoff and landing speeds using vortex generation. The only downside to such a design is that the aircraft would have to take off and land very nose high to generate the required vortex lift, which led to questions about